so how about number 2? We have division again, so let's go ahead and take care of that. Log base 3 of x minus 1 squared minus log base 3 of z to the 3 halves. So we can use the power rule and bring this out front. We have 2 log base 3 of x minus 1. There's just one term here, so we can drop those brackets. Minus, and bring this out front. So we have 3 halves log base 3 of z. That's all we can do to that one. So this one says to rewrite as a single logarithm. So we're going the other direction. They're all spread out. We're trying to combine them into just one. So let's look at what we have. Natural log of x minus 1 plus natural log of 3 minus 3 natural log of x. Here I see a number sitting in front of a logarithm, which means we can use the power rule backwards. So let's take care of that first. Natural log of x minus 1 plus natural log of 3 minus natural log of x cubed. Alright, now I see that we have addition here and we have subtraction here. So let's take care of these two first. Addition means we multiply these two, right? So we have natural log of 3 times x minus 1 minus natural log of x cubed. Now this means combining using division. Okay, so we're going to go ahead and distribute this little guy. So we're going to have the natural log of 3x minus 3 all over x cubed. Alright, how about number 2? For number 2, we have a number sitting in front of the logarithms for both of these. So we can use that little power rule, move that back up there. So we're going to have log of y to the 1/2 minus log of z to the 1/3. This means what? Divide the arguments. So we have log of y to the 1/2 divided by z to the 1/3. We're just going to leave it like that for now. Do you remember that the 1/2 power, for that one you would have the square root of y, and this would be the cube root of z, and you're not supposed to leave a radical in the denominator? So you would continue simplifying this one. For the sake of time, we're going to leave that for the other videos. Now we have the change of base formula. You know how sometimes you would have something like log base 2 of 6 and you want to get an estimated answer? Well, until you learn the change of base formula, you wouldn't be able to do that. Of course, some calculators are kind of fancy and you are able to. My calculator is not like that. So this is how you use the change of base formula. You take the log of m, this m, divided by the log of a. So this would be the log of 6 divided by the log of 2, if you were going to calculate this one. And you could even use natural log. So look at this one. Use the change of base formula to estimate log base 3 of 7 to 4 decimal places. So that's going to be log of 7 divided by log of 3. Or you could even use natural log of 7 divided by natural log of 3. It's up to you. So you just put that in your calculator. Make sure you close parentheses if you have the calculator that needs to be closed. So we get approximately 1.7712. Alright. How long to the nearest day does it take for $100 to grow to $400 at 5% compounded daily? So this is the formula for compounded interest. A equals P times 1 plus R over N, all to the NT. How long to the nearest day? So we're looking for time. Does it take for $100 to grow to $400? So this is going to be our final amount. This is our original amount. This is our interest rate. Compounded daily means N is 365. Okay, so we have 400 equals 100 times 1 plus the rate divided by N, all to the NT. So what we want to do is isolate the part that's raised to the variable. So we need to divide both sides by 100 first. That'll make these go away. And we have 4 is equal to 1 plus 0.05 over 365, all to the 365t. Now, in the last section we learned that if your variable is in the exponent, you need to do something with logs. But when we quote unquote did something with logs, all we did was switch it to logarithmic form. Now what we want to do is take the log of both sides. Now keep in mind that you can use log or you can use natural log. It doesn't matter. I use natural log just because it's easier to write. If you ever have a base E, you always want to use natural log. Okay, so what I want to do is take the natural log of both sides. So it looks something like that. When I take the log, then I can use the power rule. Move that power out front. So we have natural log of 4 is equal to 365t natural log of all that stuff. Now we have t times all of this, so we need to divide by all of that stuff. So we have t is equal to natural log of 4 divided by all the stuff that's with the t. 365 natural log of 1 plus 0.05 over 365. Okay, so the hardest part with this kind of problem is probably going to be putting it in the calculator. So I'm going to use the store button quite a bit. Natural log of 4, I get 1.386294361, something like that. I'm just going to store that in A. Okay, so if I want to make a note, I can come over here and say natural log of 4 is stored in A. Alright, then I'm going to do 1 plus 0.05 divided by 365, and I get 1.000136986. I want to store that one in B. Alright, so let me make a little note about what I did there. This one, I'll use red, and I'll say, hey, I'm storing this in B. Alright? Then I do A divided by parentheses 365 natural log of B. So we end up with 27.7277 blah 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 blah, whole bunch of stuff. It says to round this to the nearest day. So we know this is 27.72 blah 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 years, which would mean 27 years and how many days? Well, it would be 0.7277 blah 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 of a year, right? In my calculator, I'm going to take out those 27 years. So minus 27, and it's this part of a year. How many days are in a year? 365. So I multiply it by 365, and I get 27 years and approximately 266 days. So that would be to the nearest day. How about this one? For what annual rate compounded daily would $100 grow to $300 in 20 years? So this is another one of those compounded daily, so n is going to be 365. So we have a equals p times 1 plus r over n all to the nt. So we want it to grow to 300, that's the final amount. The original amount is 100. The interest rate, we don't know. The n is 365. So it's to the 365 times t, which is 20. Okay, where do we go from here? I think we need to divide by 100, and I'm going to go ahead and multiply out this exponent. So we divide by 100. And we get 3 is equal to 1 plus r over 365 all to the 7,300. Okay, so now we have to stop and think for a minute. How do we get this r out of here when the whole thing is raised to this power? How would you solve this? 4 equals x squared. To get rid of this power, you would take the square root, right? Aha! So if we want to get rid of this power, we could take the 7,300th root. Isn't that the same thing as raising it to the power of 1 over 7,300? Just like this would be raising it to the power of 1/2. Okay, so that's all we need to do. Raise both sides to the 1 over 7,300 power. That's going to make these go away. So here's what we have. 3 to the 1 over 7,300 is equal to 1 plus r over 365. Well, now it's pretty simple. We're going to subtract 1, so we get 3 to the 1 over 7,300 minus 1 equals r over 365. Now to get rid of the 365, we just need to multiply both sides by 365. So we end up with r equals 365 times 3 to the 1 over 7,300 and then minus 1. So we need to calculate this. We could probably put that all straight into the calculator. 365 times 3 to the parentheses 1 divided by 7,300 close parentheses minus 1 close parentheses. And I get this crazy number, 0.05493478 blah 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 blah. We are looking for an annual rate or interest rate. So that means we need to take our answer, move the decimal over 2 places. I think I'll just round this one to 10th place. So this 9 makes this 4 a 5. So this is approximately 5.4%. So this would be your interest rate.